Hello everyone, and welcome to section 10.4. Yay! This section has to do with matched or paired samples, also known as dependent samples. When we're using a hypothesis test to compare matched samples, we need the following things to be present. So they need to be sampled randomly, so simple random sampling is being used. Oftentimes the sample size are small. We get two samples drawn from the same pair of individuals or objects, and then what we do is we calculate the differences, and the differences form the sample that's used for the hypothesis test. So we're basically testing the differences of a certain amount of samples, okay, pairs of samples. So either the matched pairs have differences come from a population that's normal, or the number of differences is large enough so the distribution of the sample mean of differences is approximately normal. Okay, so how do we do this? We basically put the subjects in pairs and we take the difference, we subtract, and then those differences are our data. Okay, so the population mean is we test it using a student's t with n-1 degrees of freedom, where n is the number of differences, and this is the t-score formula. Luckily you have your calculator, you can use your calculator, no problem. Okay, so super fun example. A study was conducted to investigate the effectiveness of hypnotism in reducing pain. Results for randomly selected subjects are shown in this beautiful table right here. A lower score indicates less pain. So the before value is matched to an after value, and then the differences are calculated. So the differences have a normal distribution, and are the sensory measurements on average lower after hypnotism. So let's test at a 5% significant level. So we're basically taking the after and we're subtracting before. So let's say here, if I take this table and I wrote it this way, you could see clearly, okay, here's after, here's before. So the difference between these two is a positive 0.2, 2.4 minus 6.5 is negative 0.41. So this row right here, this column right here is going to be my data, okay? So that's the data. And the sample mean and the standard deviation we can find using when we do the test, or when we could do one variable stats, so the random variable is a mean difference, right? It's the difference. So since we're finding the mean of this, it's the mean difference. What is our hypotheses, right? So the null hypothesis is that it's zero or positive, meaning that there is some or more pain felt after hypnotism. Okay, so that means the subject shows no improvement, right? Because if after is greater than before, your difference is going to be positive. Okay, and if after is less pain than before, then your difference will be negative. Okay, meaning that there's less pain felt after hypnotism. So that means that it improved, right? So the difference ought to be negative to indicate that. So what are we going to use? We're going to use a student's t with degrees of freedom. How many samples, pairs of samples are there? There were 8 pairs, minus 1, so that's 7. Okay. So we use a test for single population mean. Okay, so let's go ahead and look at that. So what we do is we need to make sure that we have the list entered. So let's clear this old stuff out of there. And let's clear the other old stuff. So clear and then enter. There you go. Great. It's now starting over. And we just enter all of this real quick. Negative 1.6. Okay. And then, okay. Sorry guys. Okay, so once you have all your data entered, okay, so that's all our data. It's not that much. Not like other times it was like a lot of data. Okay, so then so we're going to hit stat, okay, and then go to tests, and then we're just going to do a simple t-test because we took the differences and that difference, those differences is our data, or are our data, you know. So what was the mean difference? The hypothesis that it was 0. The list is L1. Frequency, the alternative hypothesis is that it's less than 0, and then we go and we hit calculate. All right, and there it is. We have our p-value, our t-score, x-bar, and standard deviation. Now, if we want to graph it, do the same thing, but instead of calculate, I want you to hit draw, and then you can see the graph. There it is, and it's really tiny. Okay, so that's basically it for that. Because it's such a small t-score, a small p-value, we're going to reject the null and support the alternative hypothesis in the example we just did. Okay, so then finally here, let's do the next example. We have 7th, 8th graders at Kennedy Middle School measured how far they could push the shot put with their dominant hand and their weaker hand. They thought they could push equal distances with either hand. So here it is. We have dominant and then we have weaker. Here are the 7 students. Let's conduct a hypothesis test. So we take the differences, right? Weaker from the distances with the dominant. And this is our data here, right? So we did dominant minus weaker, and this is what we have here. And these differences have a normal distribution. So now we're going to calculate sample mean and standard deviation. When we run the test, it gives this all to us anyway. The random variable will be the mean difference, okay? And the distribution is T6 students T. And then what's our null and our alternative hypothesis? The null hypothesis is that it's equal either way, right? So if there's equal, that means there's no difference. So the difference would be 0, okay? And then, so they're testing to see if they could push equal distances. And then and the alternative would be that they can't, that's not possible, okay? So we assume that they can and see what happens. Okay, so let's plug this into our calculator. So stat, edit, and then we need to replace that with the differences. I think I did that already. And then t-test, data L1 frequency, and then different, and calculate, enter, and there's our score. We have a p-value of 0.0716, x bar s. If we wanted to do the graph, we can do the graph also. Same thing, go down to draw, okay, and then hit enter, and there it is. It's a two-tailed test, right? Because we have does not equal. So that means that half of it is going to be here and half of it is going to be here. So if we use the data directly, we get a p-value of 0.0716, okay? And so what's our decision? So if we assume that alpha is 0.05, alpha will be less than the p-value, or in other words, the p-value is high, so the null must fly. You know, we don't reject it, basically. We do not reject the null hypothesis. So we conclude at the 5% level of significance from the sample data, there is not sufficient evidence to conclude there's a difference in the children's weaker and dominant hands to push the shot put. Okay, so that's it for 10.4. Your practice is 63 through 77. So I will see you in the next video. Very excited. Good luck and happy studying.